So my name is Matan Cohen, and I'm a software development group lead at Wix, the production platform at Wix.
Hi, my name is Ryan. I am software development team lead here at the production platform at Wix as well.
And of course, we have Armon here. Hello, Armon.
Hey, how's it going? Thanks for having me.
Thank you.
Thank you for joining us.
Thank you for joining us. So I wanted to start with this thing that some of the difficulties that we have in Wix. And we wanted to share with you and hear what is your journey in HashiCorp. So my group is responsible for building products in the DevOps areas. Like in a small scale from HashiCorp, but we are building a products for DevOps, and our group called the DevX for infrastructure. So we are responsible for the dev experience, and we are building products in order to make the production engineers' life easier. Now, this is a very unique situation to be, because this field of DevOps, product for DevOps, it's quite unique because not all the people have the skill set to do this kind of job. For example, you need to have a product manager, for example. We are doing the product manager. We're the product manager of our products. And you need to find the right people. For example, if you're building products for DevOps, you need to have programmers that know infrastructure and vice versa, or you need to have DevOps that know how to build products. So in HashiCorp, you've done it in a so large scale. So how you overcome those problems and issues, and in general, how you build such a huge company that's building DevOps products?
Yeah, no, it's a great question, and it's definitely a tough challenge, right? Because as you sort of mentioned, it's a pretty specialized skill set. I think for us, part of it is a bit of self-selection, right? It's like, I think as you're hiring software engineers who want to work on infrastructure, right? It's a bit of a different breed, right? Like there's a lot of folks who they want to work on the end product, they want to do things that are in front of the customer, right? Like they like sort of having that user interaction. And then there's the folks who just really love the plumbing of it, right? And it's like, yeah, I don't really want to deal with the user. I want to build the deploy system, or I want to build the infrastructure management or secret management or whatever. It's the kind of core plumbing stuff. So I think part of it is sort of you're hiring for a slightly different mentality, right? You're hiring for folks who like that kind of plumbing and that sort of infrastructure layer. I think the other side of it is a lot of engineers, they're just unfamiliar with it, right? Like, and it seems more intimidating, I think, than, if you're like, hey, you're going to go work on this front end thing, you kind of know what that is. It's not as intimidating. When you're like core infrastructure, you're like, that seems like it's going to be like hard or scary or whatever.
Yeah.
So I think part of it is just getting people exposed to it. And then I think you find that a lot of software engineers find that problem space exciting, right? Like to me, for example, I think back on, before HashiCorp, I worked at an ad company, and you're like, well, is an ad company going to be like that interesting? You're just serving ads or like whatever. But when you start talking to people about like, what are the constraints and the challenges, where you're like, hey, you're working at immense scale, right? Hundreds of thousands of requests per second, right? You super care about performance. Every millisecond matters. You have to have responses in under 50 milliseconds, right? And you're super razor, conscious of your margins and your cost. And so when you start talking to people about those constraints, then they're like, oh, that's actually a pretty interesting problem space, right? Like, yeah, set aside the fact that it's serving ads, like the technical problems are interesting. And I think infrastructure is sort of the same thing. If you just talk to people about the plumbing, it's kind of boring. But if you talk to them about like the constraints of like what you're helping solve for, which is like, hey, how do you help make another 500 or 1,000 engineers productive? And like, if you can solve some of these sort of like underlying infrastructure problems, here's how you're going to improve our cost or our agility or our security posture or whatever. And then I think people get excited about like those things as opposed to like the plumbing of it. So I think it's about a few of those different things, which is like find people who are excited about it, do the right storytelling and like what's interesting about the problem, not just describing the plumbing of it. Cause I think that's like, and I think just give people exposure, right? So they don't feel like they're kind of like, oh, infrastructure is the scary world. I can't do that.
And did you felt that it's the same for product managers as well? Of course that for developers or for DevOps, or it's maybe you can make them interested very much about the core functionality and build such product. But sometimes, for product managers, they want to be in the position that they have like, you know, in HashiCorp, maybe this is the main product, but they want to be very close to the business. But
Right.
for other companies, sometimes the products of DevOps, for example, it's kind of a gray zone. It's like, it's not, you're not on the front of the stage. So
Yeah.
so
No,
how did you,
it's a hard problem. I mean, we have that problem internally too, right? Which is like even our own platform team, because we have a platform team, as you would expect, even within HashiCorp, even though we make platform software. And so even our own platform team has this problem of like finding the right PMs who want to fit into that. And I think we have a few, and they're great. The challenge is they are really, really hard to find, right? Finding PMs who want to work on internal platform is really hard. I think the flip side of it has been having our engineering managers take on a bit more of that kind of leader role, product management leader role, plus supplementing it with technical product management, so TPM. So we've sort of assisted, and I said, hey, we have TPMs who will help run more of like backlog management and kind of the communication across the different orgs and keeping all the stakeholders up to date. So some of the more like communication side of what a PM does, and then letting the eng managers drive a bit more of like the product roadmap, if you will, for it. And then in a few cases, we do have PMs, but it's hard. Yeah, the internal stuff is really hard because a traditional product manager, they want to spend time with field, they want to spend time with customers, they want to spend time sort of outbound, and like it doesn't exist as much for an internal product.
Right.
Yeah, and they also are not always familiar with the problem itself. Like most of the product managers know business logic, and they are not aware about the DevOps difficulties, infrastructure deployment, and all this stuff.
I mean, it's very easy to tell, for example, to product managers, for example, that works in Uber. It's a problem they know. They have this problem. They understand the field, but sometimes the engineering product, when the core of the product is engineering, it's much difficult. As you said, we took on ourselves to be the product managers as part of our job. So we are feeling very connected to what you just said.
And what I would say is like where you're going to find those people is you have to go hire them from sort of deep infrastructure companies, right? Like they have to be coming out of sort of storage, networking, compute, right? Like that's where you're going to find those PMs who have that deep familiarity, because like you just have to spend time in the deep plumbing for it to really make sense to you. Otherwise, you're just like, okay, I don't really know what we're talking about here.
Yeah, I see.
Okay. Armon, we are at Wix are using a lot of HashiCorp products like Vault, Consul, Terraform, etc. And we saw that most of these products are built on top of Golang. And I know that nowadays, like a lot of infrastructure related products are built using Golang. But back then, when you just like started the company, it was an immature language without much community. And it's kind of a risky decision to take it back then, and like not going with like some language like Java with that was very popular back then and still today. So what was the decision behind it? How did you take it? I mean,
just want to say that we love Golang and we are using it as well. We just want to see how brave it is to take this decision back then.
Yeah, no, it's a really good question, and we spent a lot of time debating it. So, you know, if we go back to sort of 2012 when we started the projects, this was a big question for me and Mitchell, which was like, what language do we bet the company on? And at the, you know, me and Mitchell, you know, we played with a bunch of different languages, and so kind of coming in, we had, you know, it wasn't like we were particularly Go experts or something. It's actually most of our time we'd probably spent with Python in the previous company. We'd done a lot in Erlang, reasonably comfortable in C, C++. So I think there was a few different questions for us, which was like, one, you know, how easy is it to package and distribute the software? So Vagrant famously is in Ruby, and packaging and distributing a Ruby application is a complete nightmare because you need to ship the whole Ruby runtime. It dynamically links to a bunch of libraries like OpenSSL and libxml and all of this stuff. And so you have to manage all of that versioning super carefully, because if someone, you know, if it links to the wrong version of libxml and then the library doesn't work, then Vagrant crashes, and it's like, it's just like horrible nightmare when you have that sort of dynamic linking on a desktop product like that. So we figured it out with Vagrant, but we're like, it's horrible. We don't want to do that again. So we want something that can link into sort of a static binary that's fully sort of self-contained. So there's a bunch of great choices for that, right? Like you can do that with C, C++. You can do that with like Java, right? And build sort of a fat jar. but you can't really do it with something like Erlang. Like Erlang is kind of a super nightmare to distribute. Like it also has like a billion files and a runtime and all of that kind of stuff. So we're like, okay, something like that's going to be challenging. So that was one concern. The second concern was like, is it good for building high performance networking software, right? Like a lot of what we do, if you think about, Vault, Console, Nomad, it's like, these are systems that are designed to process tens of thousands of, in some cases, hundreds of thousands of transactions per second. So it has to be a relatively high performance language for sort of what we were doing, especially like network oriented stuff. So you're like, okay, that like kind of rules out Ruby, rules out Python, right? Like they're not particularly performant in like multi-core and networking type of use cases. So like, okay, you can obviously C++ is a good fit. Java is sort of in the middle, right? Like, as anyone who's tried dealing with high performance Java knows the nightmare of like tuning garbage collectors and like your heap sizes, and it's just kind of a pain to deal with it. When you care about the performance. You're like, but things like Erlang were a good fit. And so that was the second concern. And then the third concern was like hiring, which is like, how difficult is it to like hire and onboard and train people for this? So like, yeah, Ruby, Python, great, really easy. C++ is, yeah, at least easier, right? Like C++ really hard, right? Like not a lot of people excited about writing C all day. Erlang, there's like 12 people in Sweden that know how to write Erlang. So you're like, not super helpful. So we kind of looked at all this stuff, and it was kind of like Go was showing up around the scene. So this was like before 1.0 even. Like this was like Go, whatever, 0.8 or something. And so we're seeing Google is doing some stuff with Go, and we're like, well, it fits the bill on distribution because it compiles down to like a single static binary. So like, that's really nice. And then they've made a lot of great decisions around like minimal runtime. Yes, it has a garbage collector, but it's very different than Java. So it's like, it doesn't have nearly the same sort of garbage collection performance problems. And it's designed to be a systems language, right? So it's like high concurrency, Go routines, all that kind of stuff. So like, okay, it fits the bill in that second piece, which is like, feels like it'll be a good language for high performance network software. And on the third one, the hiring thing, what we really liked about the syntax was like, yes, nobody really knows Go at the time, but it's not that weird of a language. Like if you know Java, you can pretty easily pick it up. If you know C++, you can pretty easily pick it up. Even if you know Python, Ruby, like coming to Go, it's not that weird. So it's like, no matter what you know, you can kind of come to Go, and it'll take you, a week, 2 weeks, 3 weeks to really kind of get going, but it's not like weird the way like Erlang is weird, or hard the way C++ is hard, right? Where it's like, it takes you years to get good at it. And so we're like, okay, kind of fits all those boxes. The biggest risk was you're like, what if Google abandons it? They kind of abandon everything else they do. So we're like, that's the biggest risk. But we thought, hey, it's a good bet because worst case scenario, like it's still open source. The compiler will still be around. Like, it's not going anywhere. And two, because the community is early, we thought, hey, as HashiCorp, like we can become like one of the places to go to if you want to write Go software. And we can help kind of define what the whole Go ecosystem looks like. And I think it's fun for us because almost any major Go project we see, there's like a HashiCorp library in it, right? Like whether it's a library that Mitchell wrote or I wrote, or it's like a HashiCorp maintained one, it's like you see our stuff in sort of the whole Go ecosystem. And so I think it was like by virtue of being early in that community, we could help kind of define it. So those were all the different reasons that ultimately said, hey, let's go make a bet on Go. And it ended up being a great bet. And Google has done a great job stewarding it and driving the development of it. And it's awesome to just watch every generation. It just gets better. The garbage collector gets faster, right? Like all of these problems just keep getting better and better with it. So we're like, it's been a good choice.
Yeah.
Cool. We also really like to develop in Golang, and I guess it was a good bet. I mean, if you could like go back in time, you wouldn't change anything, right?
What I would change is we should have done Vagrant in Go to begin with. We're now like rewriting Vagrant into Go, and it's super painful.
Regarding what you said about taking people that know Python, they will be comfortable with Go and Java and C++. I heard by the time that, I don't know if it's a myth, but I remember that I read it that what actually Google thought, the people that from Google that created Golang, this is what they did. They like merged like C++, Java, and Python, theoretically speaking, and they created Golang from that. So it's very
when you can feel it, right? When you use the language, you're like, oh, it's clear this was sort of like came from C++, and it's clear this came from Java. Like you can see the influences.
It goes without saying.
Yeah.
Okay, to another topic. So when a new company like trying to find like a solution for orchestrating containers, the go-to solution nowadays is Kubernetes. And in HashiCorp, you also have a product for scheduling containers and other services that is called Nomad. So why do you think like the vast majority of the community went more with the Kubernetes approach? And do you think that there is like maybe better use case to choose Nomad over Kubernetes for special use cases or something like that?
Yeah, it's a super good question. It's one we spent a bunch of time thinking about, which is like, why did Kubernetes sort of like win the market, I think, broadly? I think ultimately the lesson for us is it comes down to, ecosystem, I think is the biggest difference, right? Because I think what Google did with Kubernetes, by virtue of sort of putting it into CNCF and creating sort of a foundation around it, they then drove this sort of big tent around it of all these other vendors that were all pushing it. So it wasn't just like Google talking about Kubernetes, which they did, right? Like they hired 100 engineers and spent 10 million a year on marketing. But then they also had Red Hat contributing to it, and IBM and Cisco and VMware and, pick your favorite, right? And so each of those companies was then involved with developing it, marketing it, sort of advertising Kubernetes. And so I think this created just this enormous surface area of kind of mindshare generation for Kubernetes, and just helping educate users on it and going to CNCF and KubeCon and all of those kind of things. Where with Nomad is a much smaller group, right? It was just like HashiCorp talking about it at, we would obviously talk about it like HashiConf and our events, but it's a much smaller audience than like who, Google and IBM and Microsoft and Cisco and everyone can sort of advertise to. So I think that's a big part of it, was there was just this much bigger ecosystem that leaned in. I think once it hit sort of a critical mass, I think anyone who's tried to self-run Kubernetes realizes it's an operational nightmare. And so there was a ton of pressure on the cloud providers to say, hey, you need to just provide managed Kubernetes because nobody wants to run this thing. And so I think once they had GKE and AKS and EKS, then it was like, hey, now there's this like easy button. I can just like make Amazon deal with it or Google deal with it. And it's like, it's their problem versus like, I don't want to operate Kubernetes in the same way I probably don't want to operate Nomad, right? Like I just want to be a user of it. So I think that really helped then flip it, which was like, I think the dynamic would be very different if everyone had to actually operate Kubernetes, right? Because then they'd be like, holy cow, this thing's like way too much work. But I think making the cloud providers deal with it is honestly what sort of led to I think the big broad market adoption of it. So I think that's what ultimately led to it. Looking back, it's not clear. I think there's maybe some things we would have done differently, but I think it's like that dynamic of having 10 of the world's biggest vendors all lean on the same thing is like, it's a very difficult dynamic to sort of compete with.
Yeah, it makes sense. Cool. So as I said before, our group is responsible for besides of bringing some tools and products, we are helping to automate some, processes in Wix, in the infrastructure processes that need to have automatic way, for example. So let's say that you want to create a database, you need to have like a flow, a backend engineer, you need the database and some other stuff. So you need sometimes to create Terraform as a service, kind of. So for example, I mean, of course, DevOps writing Terraform all day, and this is like their code, of course.
Right.
So like 2 years ago, we needed to find a way to write Terraform programmatically. And we have our own languages. We are writing in Node.js and Golang and many others, but we needed to find a way to write Terraform like programmatically. And we were very glad to see that there is Terraform as JSON and not to like have like templates with HCL and some crazy stuff. And it was like amazing. And we've created a bunch of abstractions on top of that. We are using gRPC and REST and other stuff in order to write Terraform as JSON. And we found out lately that there is a Terraform CDK, which seems also very promising. Now, we saw that there is also Go and TypeScript and many other languages to support it. And we want to understand from your vision, what is the best or maybe which time you need to go with the Terraform as JSON and when you need to go with the CDK. That's it.
It's still in the beta, right? like the CDK, or it's out of the beta?
Oh, that's a good question. I think it's out of beta. That's a good question.
Okay. Anyhow, regarding the vision.
Yeah, that's a good question. I know there's like a whole team that's all they work on, so I'm pretty sure it's out of beta. But yeah, it's a really good question. So I guess maybe the way we more broadly think about it is it's like ultimately like Terraform core, the Terraform engine in some sense, like doesn't care what the input format is, right? Like at the end of the day, all of these are sort of, to use a bit of compiler language, all of them get translated into an intermediate representation for Terraform anyway, right? So there's sort of many different kind of language front doors for Terraform, and then all of it gets compiled into sort of the IR, which is what Terraform actually uses to sort of execute on and like process the graph basically internally. And so our review, as we sort of thought about it and said, okay, great, like obviously you don't want humans to write the IR because that's terrible, right? So it's like, what are the different front doors that actually make sense for people? And so I think the original where we started was JSON, right? So JSON was always the kind of like closest match in some sense to like what the internal IR is. The problem with JSON is like, it's kind of painful to author it, right? Like it's pretty verbose. Like you don't want to actually sit down and like write it in JSON. Like it's just kind of, it becomes a nightmare to deal with it once you have too many levels of nesting and things like that. So HCL was really born out of saying, hey, we think that like 80% of Terraform usage will be like more humans sitting down, writing it, kind of owning and curating, like, what does my core VPC look like, right? Like, what should this module be? So like our expected use cases that like 80% of the time is sort of like hand curated. And so HCL was meant to be like the easy to read, easy to write, way less verbose version of JSON. And so they've always had sort of a one-to-one compatibility with one another. But one is obviously way less verbose because that's what it was designed to solve. The JSON piece always filled that gap of like, hey, people were like, I want to auto-generate Terraform and like programmatically, and then things are like, that's the perfect fit for it, right? I think the evolution with things like the CDK have now been people saying, you know what, as I'm going sort of away from my ops person being the one responsible for Terraform, closer to my developer, the developers are more comfortable thinking less in terms of configuration and more in terms of like whatever native programming language they're used to. And so can we have an alternative for them, which is still designed for when you're like, you know, manually curating it, you're writing it, like you're sort of like, in the same way the operators are curating the HCL, your developers are curating, let's say, the TypeScript in this case. That's really what I think the CDK is more meant to solve. I think if you're building it into a pipeline and programmatically generating and putting it behind things like REST APIs, the JSON format's probably still the best, because I think that's going to give you sort of the total flexibility to do whatever you want. Or like,
you can use whatever language you want.
Yeah, you can enforce different policies, you can put your access controls, you can do all of that kind of stuff. And then you're just passing the JSON through the layer. Of course, you could still have users write it in CDK and just have that emit the JSON. And then you can pass the JSON further down the pipeline. But I think you have a little bit more flexibility with like the raw JSON than even you do with the CDK, right? Because like that's truly, you can kind of generate it however you want at that point.
Right.
Because it's closer to that raw IR within Terraform, basically. So for us, ultimately, our vision is like there's many different front doors that are optimized for different audiences, right? HCL, we think, will be the 80% use case. You know, I think CDK is probably, you know, 10% use case, and then JSON is probably the other 10% use case where you're like programmatically generating it. But our view is like all of those are valid and all of those are going to be things we support. And in fact, we're working on adding more languages to CDK. So it's, you know, our view is the more the merrier.
Yeah. It's it was very interesting for us because I mean probably I don't know if we would pick up like the language, like to use CDK if we had like CDK like 2 years ago, like mature in Golang or in another language. It's very interesting what we would pick up because it's very interesting vision wise, because we have the JSON and it's very easy to manipulate, as you said, but the other languages, to use it like in your own language, it's something that maybe, as you said, like developers with tended to infrastructure, it's more close to what they are doing. So probably they would pick up with this.
Well, the risk that I find with them, this is always the challenge, right? And this is, we were always had this trade-off even with HCL, is the more power and flexibility you give people, the more they can shoot themselves in the foot. Right? And this is the sort of trade-off, right? And it's like the perfect example of this is C and C++. It's like you can do whatever you want, including blow your leg off. Right? Like you want to access, random memory space, you can do that. Go for it. Right? And so you have this incredible power, but it's really easy to mess things up. Versus you think about a language like Java or Python, it's way more restricted. It's like you're wearing a straitjacket, right? Like you can't access arbitrary memory, right? Like it doesn't let you do that. And so as a result, like there's a lot less ways to blow your leg off, right? Not that you can't do it. And so I think that balance with HCL was sort of the same thing. We wanted enough flexibility and power, but we purposely constrained the language in a way that we're like, you can't do arbitrary, crazy things in HCL. And like, you can drop me into any HCL code base anywhere at any company, and you're like, within 30 seconds, I have a good sense of what's going on, right? Because it's like, you can only do so much weirdness. Versus the problem with the raw programming languages, and you see this, you already see it with CDK, is that you're only limited by your imagination, which can be a problem because some people have a very active imagination. And so you start coming in and there's like arbitrary Python hierarchies of classes and meta classes, and like they're auto injecting things. And you're like, it takes you 5 days just to figure out like this S3 bucket, like how did it even come to exist? Why does it have this name? Because it's inheriting all these properties in these weird ways, right? So that's the problem, I think, is with a native programming language, is like it opens Pandora's box to doing whatever you want. And I think sometimes developers get a little overly creative on it, where you're like, how the hell is this infrastructure even being generated? Doesn't even make sense.
I actually saw like a blog that there is someone that is handling his Spotify playlist with HashiCorp Terraform, which is pretty funny and amazingly how people are so creative. You have your you can use your SDK or something, man. But he used to Terraform, so he went for it, which is pretty amazing. And by the way, this is actually leads me to the to our next topic, which I think that this is what bothers us most of, I don't know, the last 6 or 5 months. So we are thinking of how to treat infra code in general. And Terraform, of course, we're going to discuss about Terraform because this is our main conversation and our main language that we are using. So from one hand, Terraform, it's a code, it's infrastructure as code. But from the other hand, it's a definition. Now, in the new versions of Terraform, there is like for loops and other stuff, which brings this to be more code in general. So we came from the development experience. So, there is a Node.js application, Golang application, you have a CI, you have a CD, you have local dev experience. And for each one of them, you have like a view of how to use it. So for example, for a Node, you will have a jest for testing, you will have that in the deployment, you will have a canary, blue, green, and some other stuff. And in the CI, containers, images, etc. But because we have so many production engineers and DevOps in Wix that writing Terraform on daily basis, more than 100, it's like a small R&D. It's crazy. And we need to figure out how we can take infrastructure as code, and we need to understand, are we gonna treat it like code? Right. And we picked up with a way that we said, okay, we are going for it big time. We are gonna spend everything to make infrastructure as code, as application, from the development to the production. And this is what we want to share our thoughts with you and hear your opinion regarding Terraform. Because as we see, we have a lot of friends in the industry and other companies, and we are discussing with them about their solutions about Terraform, and each one of them is building an abstraction on top of this. Terraform remote execution, there is the Terraform cloud, and Atlantis, and many others.
Everyone has their solution.
And yeah, everybody have its own solution. And we wanted to hear from you, what is, from your perspective, the best practices going from the development to the production in infrastructure in Terraform? It's a big question, but it's
No, it's a really, really good question, and it's one that we think about in terms of like, how do we need to like evolve Terraform? So maybe I'll answer it in a few different pieces because I think there's a few different components to it. So I think the first piece of it is sort of testing. I think we often get this sort of question of
course,
how do you do testing with Terraform? And I think even if we sort of talk about testing, you're like, okay, well, what kind of testing are we talking about? Because I think one type of testing is like, I'll call it almost like unit testing with Terraform.
right.
Which is like, you know, I asked Terraform for an S3 bucket, and then when I run it, did I get an S3 bucket? And at that level, our view is sort of like, well, it almost doesn't make sense to test Terraform at that level. For an end user, it makes sense for us, but because you're like, what are you testing? Like, are you testing that like when you ask for a VM that it gave you a VM, or that you asked for S3 bucket, it gave you, you're like, if it doesn't, that means like Terraform's just like fundamentally broken, right?
Right.
So, and you're like, you know, in some sense, it's like, are you just testing that like I typed in S3 bucket and that like I'm validating that that's what's in the file, right? Like, so our view is like, okay, unit testing doesn't make a lot of sense because Terraform is declarative. Like you're just declaring what you want and it's Terraform's job to make it happen. And if it doesn't, that's a Terraform bug. It's not a bug with your code. So moving up a higher level, it's more about like, okay, is it more like integration testing? Which is you said, I want a VM and a load balancer and a DNS record. And then, you know, when I talk to the DNS record, I should get, you know, a 200 OK back, right? Like the traffic should flow from the DNS to the load balancer to the VM. And so what I'm really trying to test is more like the integration testing or the functional testing, which is like, once Terraform finished running, is it running the way I think it should be running, right? And then there's sort of like what I'll call almost like the sort of ongoing kind of like, what's the best way to put it? It's sort of like assertions about my infrastructure. Like I expect these things to always be true about it, right? Otherwise, like something is wrong. Like a good example is like my SSL certificate should always be valid, right? Like I shouldn't have an expired certificate on my load balancer. That's a good example, right? And so that's the kind of thing where you're like, I don't want to deploy with an expired certificate. And like, I want to know if it's going to expire in the future or if it has expired. So like, I understand what's wrong with my infrastructure. So there's almost these different layers, which is like unit testing where you're like, are you testing that Terraform works? And like, that's not really, it shouldn't be the user's problem. Integration or functional testing, which is like, does your infrastructure function the way you think it does? And then all the way up to like kind of monitoring black box sort of validation of like, is it staying in that condition that I thought it was in? So as I kind of look at like what the ecosystem has done around it, I think there's some people who get really, I'll call overly into the unit testing side of it, which feels like kind of counterproductive, honestly, right? And I think at the integration testing, there's been good stuff in the community where people have built their own, like TerraTest is a good example of like, a lot of people do a bunch of stuff with TerraTest and Test Kitchen at that kind of like integration testing level. And then I think at that kind of continuous monitoring level, there's a bunch of tools around like drift detection and things like that, which is like, hey, we ran Terraform, has things changed in the meantime? Like have we drifted and there's something wrong? So the way we're sort of thinking about each of the layers, right, is, you know, great, unit testing will continue to improve that story at HashiCorp and people shouldn't think about it. But at the integration level, some stuff you'll see actually from us early this year, maybe as early as sort of this quarter, is starting to bring in what we call sort of like pre and post conditions into the Terraform configuration. So you can define sort of like, hey, the post condition of my DNS, you know, resource, for example, is that if I curl this resource, I should get a 200 OK back, right?
Right.
So you're starting to be able to declare sort of like in line within the Terraform code, like, hey, the precondition is that like, the precondition to the DNS record is the load balancer should exist. So I can test that before I even bother with the DNS record. The post condition is after the DNS record is created, it should return a 200 OK. So you can start to bring that declarative definition in. So as Terraform is actually doing the execution, it's validating these pre and post conditions and assertions as it goes. And then ultimately we want to give you different failure modes. So you might want to say, hey, let's say a good example is I have an expensive RDS database, right? It might be like some huge RDS database that's expensive. I might have a precondition, which is like, before I create that thing, make sure this is true. And if my precondition fails, halt execution. Like don't create the expensive database because some important thing is wrong. But you might also say, actually, it's okay if my assertion is false, continue creating the resource, but return an error at the end of the Terraform run. So you can start to have these different behaviors, which is like, do I just want to error the run? Do I want to abort the run? Is it just a warning, right? Like just return a warning message at the end. That's like, this thing failed. Your load balancer is not returning a 200 OK. That's probably bad. But so don't error.
This basically will run during the apply or during the plan, whatever. I mean, and there will be like a post condition that if the apply didn't return at the end 200, okay? So you have the choice, as you mentioned, you have the choice to fail but it leads us to another point that sometimes it's hard to do rollbacks in the world of infrastructure. Because
we'll come back to that one. We'll talk about rollbacks.
Okay.
So that's like kind of the functional level, is that kind of like middle layer of like pre and post condition that we're going to bring into the language natively. And then at the very top level, that sort of black box is a notion of like, where, you know, we're thinking about kind of a first class in the way like resource and data are first class, is a first class assertion. So you can put in this first class assertion, whether around it's a module, a resource, a data, basically you can take any Terraform input and basically make an assertion about it and say, hey, my SSL certificate, like fetch the certificate from the load balancer. That thing's, you know, time to live should always be at least 30 days. And so now at that top level, you can see how then that'll get incorporated into things like Terraform Cloud, where we can say, hey, I want to just run the Terraform sort of plan and drift detection every 10 minutes. And so it can tell you, hey, for example, you asked for 5 VMs, now one of them is missing, there's drift. Or it can tell you, hey, all of a sudden this assertion that your certificate's valid is now failed. Because now that certificate's only valid for like 29 days and not 30 days anymore, right? And so you might want to know about that assertion so you can go change it before you have an outage or whatever. So that's kind of the evolution of, I think, where testing is going, is basically baking in pre and post conditions. So the functional test is part of Terraform's execution, and then bringing assertions in so you can actually do that kind of black box testing on sort of a continuous basis, and really starting to do more sort of like continuous monitoring and drift detection as part of things like Terraform Cloud, basically. So that's kind of the direction we're taking Terraform testing. Then I think we'll round out the story a little bit, right? Because I think today it's kind of like you have to use TerraTest or Test Kitchen or whatever, and we'll just bring that native into it. I think the second thing you brought up was that like the deployment experience of it, of like blue, green, and how do you go from dev stage prod, whatever. And so again, I think the ecosystem has done some good tooling here, like TerraGrunt as a good example of like they have a notion of stacks and multiple workspaces and things like that. So we're really working on bringing the notion of multi-workspace as native to Terraform. So you might say, great, I have a dev workspace, staging, production workspace, and they have a relationship, right? I'm going to promote from one to the other. Or maybe I have, you know, 5 production environments, right, in different regions. I want to first deploy it to whatever, UK 1, and then from there I deploy to, you know, France 1, Germany 1, so on and so forth, right? So you might have a relationship between these different workspaces. And I think that notion of a stack, or, you know, whatever we end up calling it, a multi-workspace type thing, that's another big thing we're looking to solve this year, to fix a bit of that deployment pipeline thing, which is like, okay, you should be able to define what that pipeline looks like in Terraform, and then it helps you manage, you know, the upgrades of the code version or variables or, you know, whatever it is that you need to flow through that kind of pipeline. So both of those, I think, hopefully you'll see a much, much better story this year as we sort of add that to the Terraform core language and core like runtime, as opposed to needing to kind of piece together a bunch of community tools to do it.
This is a definitely feature that we are looking forward to use. Like we are right at this moment, like thinking about how to develop this stuff, and it's very good to hear that you are working it to release it as part of the core features of Terraform.
Yeah,
so it's very exciting.
It's definitely
I mean, probably in companies that have just 2 regions, for example, as you said, like US and maybe Europe. So it's not like a big deal, like to do a plan, apply, check the metrics, check the monitoring, and, you know, they change the modules. But when you have like 20 data centers, for example, so this is what we are solving at the moment. We need to solve multi-DC management. So we need to, I mean, we are a DevOps, for example, right now should go and change the module version, for example, and just a tiny thing, but it needs to go tediously, DC by DC, plan, apply, monitoring, and God forbid you need to do a rollback in the 19th, and this is crazy. So this is one of the main issues that we are facing today. And if you are multiply it by the number of infrastructure people in our organization, so they don't have like a clear solution for that. So it's amazing to hear that.
Like on your point on things like the monitoring and the fact that, you know, this is the platform teams are the ones doing this. I think that where it gets really challenging is then from the application team's perspective, where they might not even know what metrics to go look at. Like they're not the infrastructure experts. Like the platform team, yeah, they know what to go look at, but the app team doesn't really care. They're just like, I want to deploy my app on whatever. And so I think that's where things like, hey, can the platform team put those assertions into the Terraform modules, into the Terraform code. So if I'm the app team, I push my deploy button and it's like, oh, this assertion failed because my Datadog metric is like off now.
Yeah.
Okay, now that's a thing I know now I need to go look at that metric, but it's like otherwise like the dev team might not even know like what metric they should go look at.
Yeah.
So I think that's some of the stuff where it's like, can we close that loop and like bring those, those metrics that you're looking at, put them in the Terraform code so the dev team doesn't have to know about it, and then have an opinionated workflow on what that pipeline looks like, basically.
I want to ask another question regarding the CI. So we see in most of the, let's say, infrastructure fields, there is kind of an artifact, right? So when you have like a let's take an analogy from regular application, right? So you're writing your code, doesn't matter, Node.js, Golang, etc. And then you have probably Docker image, and then you have your artifact. And with this artifact, this is, let's say, the end of the CI. And then you're taking this artifact to the CD. Yeah. Now, in Terraform, it's a little bit different because as we see it, the most closest to artifact that we found, it's a module, kind of. Maybe a few modules as a collection. But the problem with the module is that it's have variables. I mean, it's not a problem. This is what it's meant to be. It's meant to be like a reusable resources.
Right. Like, module is more like a library than an artifact. Yeah.
Yeah, of course. So the problem is that if we want to treat Terraform like a code, it's a little bit difficult to treat it like something that is sealed and closed. And maybe I can give an analogy from another area. For example, what Helm did to Kubernetes manifests. So they took several Kubernetes manifests and they give it a revision, a chart. Yeah. And then we can treat it like something that it's sealed as an artifact that we can take. So I wanted to hear, what is your opinion? If we are taking Terraform as code, what is your opinion about artifact of Terraform, like Terraform image, for example?
Yeah, it's a good question. And I think there's almost two layers to it, which is like the core. So I guess artifact, as we think about it, is like the thing that should get passed down the CI/CD pipeline is actually the Terraform plan. Because the Terraform plan ends up being sort of the compilation, if you will, of
with the
variable inputs, all of the sort of modules and sort of source code and state into like one atomic unit. And that's when you feed the plan into apply, that's what it's using to say, hey, atomically execute against this thing. So I think if you're sort of compiling Terraform down, it's like what you get is the plan output, right? So that's how I would think about like the literal chunk that should be passed through the pipeline. And if you think about a system like Terraform Cloud, like that is how it works. Like when it generates a plan, like when you hit apply, what it's done in the background is it's saved that plan output and then it's passing that through, and that's what it's executing to make sure that you don't have drift between this is what the plan said it would do and this is what the apply actually did. So that's the low level atomic unit. The higher level one, if we think about like most infrastructure is composed of more than one module, right? Like modules tend to be lower level building blocks. And I think the common pattern we've seen is this notion of like a multi-module architecture, right? You might have a module for your load balancer and DNS and a SSL record or whatever. So you have 10 different modules that you're composing to then say, this is a Java app, let's say.
Right.
And so that higher level thing, the Java app, like what's that? Yeah. And I think that's where we're sort of, talking about like what we're loosely using the internal language of a blueprint, where we want to basically introduce this higher level concept of a multi-module pattern that's more opinionated, it's structured, it pulls together these different things. And so I think you'll see some more from us this year around that as well, where it's like, it'll be an expansion a little bit of how you think about modules. And I think you'll see the public registry get updated, public and private registries get updated to reflect this notion of like, hey, this blueprint thing, I want to be able to come in and say like, deploy a copy of this blueprint, give me my 3 variable inputs. And then that thing is sort of a closed, like kind of like a chart, basically. It's a bit more of an opinionated thing. It's versioning the underlying modules. So I think that's kind of the direction we're going there, which is like, that's almost the source code artifact becomes the high level blueprint. And the low level one is really the plan output, which is sort of like, that's the atomic executed thing.
Yeah. So regarding first of all, it's we're very glad to hear that.
Yeah, exciting news.
Yeah, exciting news for us. Because we have a lot of difficulties understand the vision and think about it. regarding the plan, I mean, it's atomic in a way, but I mean, when we got the experience of DevOps engineers, you know, they're doing plan and apply so many times until they understand if the module, it's the, how to say, in the way they want it.
Right.
I mean, although you have a plan, it doesn't mean from a DevOps perspective that it's finished, because maybe the apply was wrong. So
right.
This is why it was hard to us to think about the plan as an, how to say, like atomic thing, like an artifact, for example.
Right.
But for other cases, of course, it makes sense and everything. And we are very glad to hear that this is the direction.
Yeah, I mean, the way I think about it is almost like if we had like a CI pipeline for an app, it's like every time I check in the app, the first thing it's going to do is compile it into the binary, and then it's going to go run all the unit tests. And if the unit test sort of fails, well, I'm not going to like upload that artifact to like Artifactory or something, right? I'm just going to throw away the compiled binary. And so to me, that's almost the same thing with like Terraform. It's like you're going to run the Terraform plan, right? It's compiling it into that plan output, if you will. And then when you're sort of looking at it, you're like, does it do what I think it's going to do? And you're like, oh no, it's something is wrong. You sort of throw that thing away in the same way you're kind of throwing the binary away and making a change again. And then once you're like, oh, my unit test passed, like, okay, that's the thing I'm going to deploy. I take the compiled artifact through. Sort of the same thing. It's like, okay, once my plan looks right, then that's the plan output that I take and actually execute. So I think there's a close analogy if you think about it as like the compiled binary, where it's like your CI is compiling it all the time. You're just throwing it away most of the time.
Yeah. Cool. So last question. What is your next vision and thoughts of what HashiCorp is going to do? And
we got a lot of hints of what is going to be happening in the future. But
if there is like a high level thing that we need to expect very soon or something.
Yeah, there's a bunch of the Terraform stuff that we talked about this year. But
of course, it was amazing.
I think the biggest, right, for the company broadly is the sort of shift for us from really like historically, we've always been like a desktop software company, right? Like we build open source stuff and then we have, enterprise versions of it, but it's like customers download it, run it, whatever. And now the big shift for us is really becoming sort of a cloud delivered business, right? And that's like a totally different motion, right? Like we're used to like, you have 4-month release cycles for our software, right? Like, it's almost like a waterfall planning methodology for us versus now increasingly as we think about like, now we have Terraform Cloud, we have an HCP version of Vault and Console, we have HCP Packer and GA, Boundary and Waypoint and Vagrant will all end up on our HCP, our HashiCorp Cloud platform this year as well. So it's really this shift towards like all of these now being delivered as also a managed service solution. And I think that'll start to bring a different set of capabilities for the products as well, right? Like, yes, there's still the core open source and you can have it just managed by us, but then it's going to be like additional capabilities that are sort of cloud delivered that might still work. Some of the stuff, like there's some really cool stuff we're working on in terms of hybrid models, where you might say, I'm self-managing console in my own data center, but I might have like a cloud-based management plane that helps, I can see all my services across all of my world and do alerting based off of it and define rules across the whole thing, where that might be cloud delivered, but I'm still running console myself in my own data center. So I think that kind of a blend for us of really being able to like cloud deliver the services and support those sort of hybrid modes is going to be super interesting for me. It's like a whole new world of like, new features for us to deliver.
Sounds amazing.
Yeah,
truly.
Indeed.
Thank you very much, Armon, for joining us.
It was a pleasure.
It was a really pleasure. Just a last thing, if it's okay for me that we can do a selfie together?
Yeah, of course, yeah.
Okay. So I will do a selfie. Just a sec. Okay.
We
cool.
got it.
Nice.
Thank you very much, Armon.
Thanks
for your time.
It was very interesting.
It was very interesting. Thank you very much.
Yeah, thanks so much for hosting. And let me know if I can ever be helpful with anything. Happy to do so. And if you guys ever have feedback on any of the Terraform stuff, please share it and send it our way.
Of course. Thank you very much.
Awesome.
Bye-bye. See ya.